Hello, I'm Grady Stone, the Regional Administrator for the Federal Aviation Administration's Northwest Mountain Region. Thank you for joining our virtual public information workshop on operations in the Puget Sound area. While some of you are very familiar with the airspace and operations at airports in the Puget Sound vicinity, we understand that this topic may be unfamiliar to others. So today, we will brief you on how and why aircraft operate as they do in the Seattle area. We will share a plain language breakdown of how we manage the airspace above you and review our typical operational flows in and out of the area. This will be followed by our question and answer session with a panel of experts. First, I would like to introduce our partner at the Port of Seattle, the Managing Director of Aviation, Lance Little, to talk about the Seattle-Tacoma International Airport.
Welcome, everyone. My name is Lance Little, and I serve as the Aviation Managing Director at Seattle-Tacoma International Airport. Tonight's FAA virtual workshop provides an important opportunity for all Puget Sound residents who have questions and concerns about aircraft noise and its impact on the neighborhood and homes. Airports like SCA regularly assist members of the public with information about aircraft activity and provide additional details like an aircraft's altitude and noise level. But the real authority on how our airspace operates is the agency that has direct responsibility for managing it, the Federal Aviation Administration. That is why I'm so pleased that the FAA has assembled a team of experts tonight ready to respond to the issues and questions attendees bring forward about the Puget Sound region's airspace. Tonight's event is an opportunity that many in our community have been asking for over the past several years, particularly those from Vashon Island and Beacon Hill. And so I look forward to seeing their questions answered by those who have direct control over these aircraft activities. Port of Seattle and airline representatives are also in attendance to assist the FAA with responding to questions. Please join me in thanking the FAA for answering the call and hosting the virtual workshop, and for their extensive effort in preparing detailed information for tonight's presentations. I also want to thank the residents who are with us tonight. Your attendance is a testament to your civic engagement and your desire to represent and advocate on behalf of your neighbors and your community. Before I turn things over to the FAA, I do want to stress that the Port of Seattle, the owner and operator of Seattle-Tacoma International Airport, is committed to taking action to address aircraft noise. Because the airport has very limited control, our efforts are mainly taken in partnership with the FAA, with the airlines, and with the community. For example, beginning in 1985 with substantial FAA funding, the port began its sound insulation program with the cities near SCA. To date, over 9,400 single-family homes, 6 condominium complexes, and 10 schools have been sound insulated. In 2025, the sound insulation work continues with, for the first time, the insulation of apartments and places of worship. In addition, the port is currently assessing existing sound insulation packages at single-family residents and will implement a pilot program for re-insulating residents that have experienced issues with their previous insulation packages. Since the 1990s, port staff has closely monitored established noise abatement flight path and procedures and have kept regular communication with local FAA staff on rates of compliance. This coordination, along with FAA technology improvements, have resulted in annual compliance rates for noise abatement procedures to reach an impressive 99% at SCA. Working in close coordination with the leadership from the airport cities, the Port of Seattle and its city partners launched in 2018 the SCA Stakeholder Advisory Roundtable. Known commonly as START, the Roundtable provides its members with a dedicated forum for discussing and tackling airport and aviation concerns brought forward from the member cities and their residents. I proudly serve as the chair. Let me now summarize some of START's major accomplishments. Launched in 2019, the Late Night Noise Limitation Program is a voluntary effort to reduce late-night noise by incentivizing air carriers to fly at less noise-sensitive hours or transition to quieter aircraft. The program includes regular reporting each quarter to external audiences and all airline noise exceedances above established noise threshold in the late night hours. Several carriers to date have upgraded their fleet to quieter aircraft based on the program. Nearby residents had expressed desires to limit noise emanating from the third runway, and so, in partnership with the FAA, the port instituted an informal runway use plan minimizing use of the third runway during the late night hours. Prior to the runway use plan, the third runway averaged 12 to 13 operations during the late night hours. In 2023, the average was less than 2 operations per night. START has also finalized aircraft noise limiting language at SCA, encouraging the limited use of aircraft reverse thrust whenever possible, promoting continuous taxi to takeoff, and encouraging single engine taxiing as established practices at SCA. At the beginning of last year, the port and the START cities sent a joint letter to the Washington congressional delegation highlighting 7 key aircraft noise and emission policies priorities for proposed inclusion in the 2023 FAA Reauthorization Act. In support of those priorities, the port and the START cities conducted the first ever joint DC flying the spring of last year. And I'm pleased to report that 4 of our 7 priorities made it into the final version of the FAA bill, including the establishment of a deadline for action on the FAA's noise policy review and the creation of a stakeholder advisory committee to have input on this policy review, including representatives of airport communities. With the success of the efforts at the federal level, START launched a major new effort in 2024 to replicate its DC success in Olympia. We just last month finalized a port cities set of priorities to share with the governor and the state legislature. They include next steps on state funding for repairing and replacing noise insulation, as well as a focus on identifying other places in the region to expand commercial aircraft operations away from SCA. I would like to end by again thanking the FAA and Grady Stone, the FAA Regional Administrator for the Northwest Mountain region. Your willingness for direct engagement with the public is appreciated and demonstrates the FAA's commitment to transparency and accountability. Let me now transition to a video on the history of SCA Airport and specifically its founding. 2024 represents SCA's 75th anniversary year, and in recognition of that milestone, we have produced several historical videos, all available on YouTube. The video you're about to view has been shortened. For the full experience, please visit YouTube to view the video in its entirety and all the videos in the series. Thank you.
You know, I don't believe we ever had any idea what would end up being here.
So the demand for travel is here now, and it's going to be there for a long time.
The airport is so different.
And it is constantly evolving and changing, particularly with technology. As a result, change at the airport happens.
That means that we have to work really hard on being effective in our planning and then our execution of that.
Most of the large civilian airfields were closed to civilian operations. Boeing Field was closed to civilian operations actually on December 6th, 1941. So that changed aviation in the Seattle area. You had these small airlines like United Airlines was flying out of here. They needed someplace else to go.
So it was clear that an airport was needed. And then there was a question of who's going to build it. And it was at a meeting of the Seattle Chamber of Commerce that it was announced that the port would take over that role. And there was reluctance from a lot of people to build the airport because Boeing Field at the time wasn't profitable. But it was clear to business leaders in Seattle and King County and Pierce County that an airport was needed. And it was also clear that an organization with innovative leaders and skills would be needed to champion that project and to fund it, because that was a big issue. So there was talk about where to put the airport, and one of the areas was out at Bow Lake, and there was a lot of land available there. When they got that area, they thought it was sufficient for years and years and years, and it was for a while, but it would be hard to really capture in people's imagination the growth that this region saw in the 75 years since that opening. They were talking about where to put it, and it was important to have it between the two major cities of Seattle and Tacoma. And then slowly things progressed. There was the paving of the first runway and the surveying before that. Those were all key steps. And then the first flight, the first international flight, those were all big moments. And then to have that central terminal open in 1949, that was really the capstone of the celebrations. And if you look at every year of the airport, from when it was announced in the early 40s into the 1970s, there was a major project and major innovation every year. And even in the decades going forward, almost every year there's been something major that has happened at SEA.
Hello everybody from Seattle-Tacoma International Airport. The Seattle-Tacoma is a real layout. And the administration building, which you see there, which cost $3 million, is considered as the most functional such airport building in the United States.
It was a huge deal to have the central terminal open. It was broadcast live on the radio. It was an event that everybody knew about. It was like a Super Bowl for the region. It was just the biggest thing around, because not only to have an airport, but to have such a grand facility. And it was one where elected officials, everybody who was anybody in politics wanted to be there, and they were.
The Port of Seattle owns and operates Seattle-Tacoma International Airport, and it's quite an operation. There is no doubt but what it is one of the finest in the nation, as any seasoned air traveler will tell you. A giant of the skies from the Far East arrives at Seattle-Tacoma International Airport.
Seattle and King County and this whole region were shaped by Boeing. It had such a tremendous influence here. To understand that innovation, to make Seattle and this region such a leader internationally in air travel, of course influenced the port, and it was such a big driver in terms of not only awareness but also action.
United 612, you're cleared over Ellensburg to Denver. And he is airborne. To us, this is still a thrilling sight, a big plane getting into the air.
This video provides an overview of aircraft operations at Seattle-Tacoma International Airport and in the surrounding airspace. We'll talk about how air traffic operates, the complexities of airspace in the greater Puget Sound area, and the procedures air traffic controllers use to keep airplanes safely separated. Seattle-Tacoma International Airport, also known as SEA, and the nearby airports form a complex airspace that operates over a population of more than 4 million people in King, Kitsap, Pierce, and Snohomish counties. The region is served by numerous airports with commercial flights, test flights, smaller general aviation propeller aircraft, business jets, and military flights. Each airport, regardless of its size or the type of aircraft that operate there, has its own airspace with dedicated arrival and departure routes that guide aircraft in and out of the Puget Sound area, connecting to the larger National Airspace System, or NAS. These airports serve a wide range of aircraft of different sizes with varying performance capabilities. It is critical to keep different types of aircraft and the numerous traffic flows separated from each other. The primary responsibility of the FAA's air traffic control system is to provide the safe, orderly, and expeditious flow of air traffic. This is done by teams of FAA air traffic controllers that ensure airplanes are safely separated while maintaining the most efficient flow of air traffic. Air traffic control requires great precision and is highly complex. When an airport is constructed, the runways are built to align with the most common wind directions in the area. This is because aircraft take off and land into the wind to maximize performance and safety. In the Puget Sound area, winds are variable, but primarily come from the north and south. Most airports in the region have primary runways that are also aligned north and south. As shown in this animation, SEA Airport has 3 runways. Since each runway end is treated as a separate surface, there are actually 6 runways. Runway identification is based on the magnetic compass heading the aircraft is facing as it lands or takes off. For example, runway 16 and 34 is oriented with a magnetic compass heading of approximately 160 degrees in one direction and 340 degrees in the opposite direction. If you drop the 0 at the end of the compass heading, you will get 16 and 34. Parallel runways are further designated with L for left, C for center, and R for right as you approach or depart the runway. At SEA Airport, aircraft will land and take off to the north or south, depending on the direction of the wind. This example shows aircraft taking off and landing to the south. In south flow, which is approximately 70% of the time, aircraft typically depart on runway 16 center and 16 left and land on runway 16 right and 16 left. Aircraft use 2 runways for landing and 2 for arrival, which creates an efficient throughput both on the ground and in the air. In a congested area like the Puget Sound, airports that may seem far apart by car are very close to each other when traveling by air. Aircraft operate using both instruments and visual references. These 2 types of flying are called Instrument Flight Rules, IFR, and Visual Flight Rules, VFR. These types of flying require different levels of air traffic guidance. However, all aircraft must maintain safe separation from each other and terrain. Air traffic controllers help manage and separate all types of aircraft, from the largest commercial jet to the smallest propeller aircraft. IFR aircraft flying at the same altitude must remain a minimum lateral distance from each other. In airspace surrounding airports, the minimum lateral distance is 3 miles. In higher altitude airspace, the minimum lateral distance is 5 miles. Where aircraft do not meet the minimum lateral separation requirements, they must remain a minimum vertical distance from each other. Below 41,000 feet, aircraft must remain at least 1,000 feet above or below one another. For example, when the airports in Puget Sound area land to the north, aircraft landing at SEA Airport and Boeing Field operate in the same vicinity and have numerous crossing routes. In order to maintain the minimum required vertical separation, air traffic controllers give compass headings and altitude direction to pilots. For example, this animation shows an SEA Airport arrival and a Boeing Field arrival. The aircraft landing at Boeing Field will stay above the SEA Airport's final approach, then continue its descent to be below aircraft on the east side of SEA Airport. Additionally, our area is unique due to the Boeing Company operations at Renton Airport, Payne Field, and Boeing Field, where aircraft are built, flight tested, and ultimately delivered to customers all over the world. In addition to these airports, there are numerous other general aviation airports in the Puget Sound area, which predominantly serve propeller and business jet aircraft with limited commercial service. Many of these general aviation operations are small propeller training aircraft that fly a pattern around an airport to land and take off. Most airports have their own voluntary noise abatement best practices for pilots to reduce impacts on neighboring communities. Not only are there operations from multiple airports in the region, but there are also helicopter and seaplane operations. Helicopters are used by the military, news agencies, law enforcement, emergency medical services, flight training, and sightseeing operations. Seaplanes are aircraft that operate to and from the Sound and area lakes. As you can see, there are many layers to managing airspace, including high traffic volume, proximity of surrounding airports, helicopter and seaplane routes, and weather. All of this is accomplished every day by a team of highly trained air traffic controllers.
Hello, my name is Sean Hopkins, and I'm the air traffic manager at Seattle TradeCon, where we manage air traffic from Olympia to Everett. I've been involved with air traffic for over 34 years. This presentation will walk you through the flight procedure poster boards for the arrivals and departures at the Seattle-Tacoma International Airport and a few of the surrounding airports. Each flight procedure board is oriented with north at the top. The name of each flight procedure is shown by an arrow on the map containing a 5-letter name. Arrows for arrival procedures point toward the airport, while arrows for departure procedures point away from the airport. For example, this board shows 2 departure procedures, Banger and Harib. These are called SIDs, or Standard Instrument Departures. The spelling of each departure and arrival procedure is limited to 5 letters. For example, the spelling of BANGR departure is pronounced banger. The stars on the board are locations of waypoints, which are fixed navigational points in space that the aircraft fly to. Just as with the spelling of the procedures, waypoints are spelled with 5 letters. For example, the ISBRG waypoint would be pronounced iceberg. Each departure board also shows radar flight tracks in purple for departures and orange for arrivals. These radar flight tracks are random sample from March 2024 and show actual aircraft operations over multiple 24-hour periods. The flight procedures are colored purple for departures and orange for arrivals. These colored paths show the existing published flight paths. Surrounding the paths are dispersed path areas in either pink for departures or yellow for arrivals. Planes may not fly right down the center of a route. These pink and yellow areas show the typical extent of the dispersal and account for the different routings needed for safety, hazardous weather avoidance, operational needs, or occasional navigational drift. When the aircraft fly in these areas, it is typically due to a pilot receiving a vector from the Seattle Terminal Radar Approach Control, also called the Seattle TRACON. A vector is a compass heading assigned to an aircraft by an air traffic controller. The standard terminal arrival, or STAR procedures, west of the airport use GPS for guidance, while the procedures east of the airport use ground-based navigational aids. From the STAR, ATC uses various methods to guide aircraft to the approach procedure, such as vectors or navigation by GPS. Like the STARS, approach procedures use various means of navigation. The procedure may use traditional ground-based navigation systems, like an instrument landing system approach, or ILS, or the procedure might use precise GPS navigation, like an RNAV approach. RNAV is acronym for Area Navigation that allows properly equipped aircraft to fly precise routes all the way to the runway. In the busy Seattle airspace, aircraft arriving or departing may be vectored off their procedure for safety, sequencing, or hazardous weather. Aircraft that are vectored are given a different heading to fly than the published procedure. The bullet points on the right side provide additional details about the procedures. This board shows an overview of airspace at 8 airports in the area. Each airport shown here has an air traffic control tower. As you can see, the airspace in our area is complex and involves numerous air traffic controllers working to control aircraft in these airspaces, as well as aircraft transitioning to and from airports. Air traffic controllers manage thousands of flights per day within this airspace that is part of the overall national airspace system, ensuring the safety of those in the air and on the ground. Aircraft in the Puget Sound area operate in both controlled and uncontrolled airspace. When aircraft are in controlled airspace near an airport, they're in contact with air traffic controllers that give them varying levels of guidance based on aircraft need, weather, and other operational requirements. This board shows the airspace we just looked at with a sample of flight tracks for multiple days in March 2024. Small propeller-driven aircraft and helicopters are more common at these satellite airports and are typically used for training, recreation, news, law enforcement, and sightseeing. Aircraft may stay at their local airport and fly in the traffic pattern, or they may fly to another airport. In addition to the airspace associated with an airport, there are also special use airspace areas south of Joint Base Lewis McChord. This airspace can be used by civilians. However, it is primarily reserved for military use and is not consistently available for civilian use. This board focuses on flight tracks for Payne, Boeing Field, SeaTac, and Renton airports. As noted on the previous board, aircraft may conduct training operations at satellite airports, including Boeing Field and Renton. Many times, training aircraft will stay within the airport traffic pattern. When aircraft fly in the pattern, they generally depart and fly straight until approximately a half mile from the end of runway, or when they are at least 700 feet off the ground. Then the aircraft will follow the pattern to land, repeating the cycle. This board shows published instrument procedures for south flow arrivals to SeaTac on runways 16 right, center, and left. South flow is when aircraft land and depart to the south, and is used about 70% of the time in the Seattle area due to prevailing winds out of the south. Aircraft arriving from around the globe are guided into 4 corners of the airspace and then sequenced for landing. We call this a four-post system. Aircraft arriving from the east are vectored, while those from the west can use a GPS procedure unless sequencing is necessary. This is a zoomed-in view of the south flow operations at SeaTac. This board shows the published instrument departure procedure for runway 16 right, center, and left. Again, this is the most common departure direction at SeaTac. When aircraft depart, they typically fly straight out approximately 5 miles and climb to 3,000 feet before turning to the east or west. Aircraft turning to the east are vectored to join a published procedure. As you can see on the map, aircraft join one of 5 main departure procedures to exit the Seattle airspace. In this zoomed-in view, we can see aircraft flying to the west are typically given clearance to fly a SID. Aircraft departing to the west may still be vectored as indicated by the aircraft flight tracks in the pink dispersed path area. This board shows the published instrument procedures for arrivals to SeaTac in north flow. Aircraft coming in from the east are vectored to intercept an approach procedure from the final point of the star. For example, aircraft on the Glacier star will fly to Heather waypoint and then be vectored and assigned altitudes to set up for a safe, stabilized approach to landing. This board shows a closer view of the published instrument arrival procedures for north flow. Aircraft arriving from the west will fly along a GPS star unless sequencing is necessary. For example, aircraft on the Mariner star, which connects to an approach procedure, are capable of continuing to the runway using the onboard flight management system to fly the procedure without additional direction from ATC. While the majority of arrivals on the west side fly the GPS arrival, some aircraft must be vectored due to spacing or sequencing purposes. This board shows the published instrument departure procedures for runway 34 right, center, and left. Typically, aircraft depart on runway 34 right and center. When aircraft depart, they typically fly straight for approximately 8 miles and climb to 4,000 feet before turning to the east or west. This board shows a close-in view of north flow departures. Aircraft typically fly within the pink shaded area that indicates the dispersion area. This board shows aircraft operations in north flow during nighttime hours between 10 p.m. and 6 a.m. During these hours, aircraft typically use the JEFPO departure, which takes aircraft over Elliott Bay and Puget Sound. Since people are more sensitive to noise at night, ATC typically uses this path during north flow. Aircraft with eastern destinations remain over water and are not turned to the east until reaching an altitude of at least 10,000 feet. During south flow, there is no different routing for nighttime operation because there's no option for them to fly over the water. This board shows a close-in view of the JEFPO departure used during nighttime hours. The FAA uses the JEFPO procedure as much as possible, but heavy traffic or other issues such as weather or equipment outages can delay or prevent utilization of the procedure. This board shows SeaTac Airport and Boeing Field in north flow. Aircraft must be separated at least 1,000 feet vertically or 3 miles horizontally. Aircraft landing at Boeing are typically lined up on a stable approach between 5 and 15 miles away from the airport. This means aircraft arriving at Boeing Field fly near SeaTac arrivals as they turn to line up for final approach. For example, aircraft arriving to Boeing Field on the Olympia arrival generally fly above aircraft that are on final approach to Seattle, then descend and fly an approach procedure into Boeing Field once clear of that traffic.
This meeting is informational only and is part of an ongoing dialogue between the FAA and their external stakeholders.
Hello again. I'm Grady Stone, the Regional Administrator for the FAA's Northwest Mountain region. Thank you for participating in our virtual public workshop. I will be the moderator for this discussion. It's important for the FAA to work collaboratively with aviation stakeholders while addressing community concerns about aviation. The FAA's role is to regulate airspace, ensure safety, and set operational standards for airports. The FAA oversees air traffic control and enforces safety regulations, while the airport supplies the physical infrastructure needed for airline operations. Airports collaborate with the FAA to develop noise abatement plans and work with airlines and the community to promote education and awareness. Airlines are responsible for flight operations, customer service, aircraft fleet management, flight scheduling, and market selection. Tonight, we've brought these three groups together. Now let me introduce our panelists. Let me begin with the FAA. Sean Hopkins, Air Traffic Manager at the Seattle TRACON. That's the Terminal Radar Approach Control. Jeremy Beecher, Traffic Management Officer for the Seattle District. And now from Port of Seattle, Sarah Cox, Aviation Director of the Environment and Sustainability. And from Seattle-Tacoma International Airport, Tom Fagerstrom, Noise Program Manager, and Ryan McMullen, Senior Noise Manager. And finally, our airline partners, Lene Craig, Director, Air Traffic Management and Airfield Operations for Alaska Airlines, and Tony Vasiliadis, Air Traffic Management, Delta Airlines. We sincerely appreciate the participation of our panelists. The challenges around aviation and noise are complex and must be addressed by the entire aviation community. I hope that the information we share in the live Q&A provide value to you. Let's begin the Q&A. The first question. Looking at the maps you've shown, it appears that aircraft sometimes fly over the water, which is good, but still overfly some populated areas on those routes. Can a slight additional turn be added to keep them completely over the water? So Jeremy, could you start with this response?
Absolutely. Thank you, Grady. So with these procedures, there's a lot taken into consideration as they design them. The first thing they look at, obviously, is the runway, where it's laid out. And as we saw in the video, that is typically laid out predominantly which ways the wind blow to help with aircraft performance. The other thing that they do consider while building these is aircraft performance. The aircraft need to be able to make appropriate turns to be able to get established on the final approach course to set up to actually have a safe and stable landing. And more importantly, when these procedures are designed, they're taking into consideration separation of aircraft in the area. In a congested airspace such as the Puget Sound area, we have many airports that we are operating in and out of all at the same time. And so while you may be able to add a turn or put them over the water, what that can do is put aircraft in close proximity to each other and in an unsafe proximity. So many times that slight additional turn would reduce that separation and create a hazard to flight.
Thank you, Jeremy. And Tony, could you share the perspective from Delta?
Yeah, thanks. Good evening, everyone. So we do try to fly the procedures that are developed by the Federal Aviation Administration, and we pretty much have to adhere to those so they can safely separate aircraft as they traverse over the Seattle area. So we're pretty much beholden to what ATC is designed for us.
Thank you, Tony. And Lene, could you please share your perspective from Alaska Airlines?
Yeah, absolutely. So pretty much similar what Jeremy and Tony already touched on. We are collaborating with the FAA when they design flight procedures to make sure that the aircraft can actually fly them that they're designed for. So there is some collaboration there. And yeah, even small changes to where that path is can be a challenge to try to fit in, again, due to the really complex and congested airspace we have with so many different operators.
All right, thank you, Lene. Second question here is, I have a general question on how air traffic controllers communicate with pilots. Are all communications done on radio frequencies? Jeremy, help us out with this.
Absolutely. So since air traffic has been around, yes, that's been the primary means of communication is through radio communications. In the last 15 to 20 years, though, there has been a new technology that's come online called Controller Pilot Data Link Communication, or CPDLC. This is essentially a technology, I would relate it to, say, texting on your phone back and forth with people. It initially started on the surface at airports, issuing routes of flight to aircraft prior to actually leaving the gate. The information would come to a computer. The air traffic controller can send via this message directly to the flight deck, to the pilots. And the pilot not only has an opportunity to acknowledge it, but at the same time, they can also accept it. And if they do that, it automatically loads the clearance or the route of flight into the flight data computer for them. And this helps to eliminate any type of misreadbacks. If somebody, they misspeak when they read back the clearance, or even if the controller makes a mistake and issues the wrong route of flight. I would say in the last 10 years, it's actually been starting to be used in the en route environment. Basically, when the aircraft are at higher altitudes in cruise, they use it for very basic communications, turns, climbs, descents, and even frequency changes. That being said, they still have the ability to communicate via radio if needed for any type of emergency communications, traffic advisories, anything like that that may not be just a standard piece of communication.
Yeah, thank you, Jeremy. That's interesting that comparing it to texting. And from past experience with doing radio readbacks, it's not always perfect, especially in my past. So thanks for that. Lene, help us with this, please.
Oh, sure. Yeah. From the pilot's perspective, Jeremy really covered it well. I think it's helpful for pilots to be able to have that written down. They don't have to, there's hear back, read back errors that we call them. And so the pilot has to hear and then document and then send it back and then acknowledge that they got it right to the air traffic controllers. So having this, the data is just much easier for them to consume that information. And then it also frees up radio frequencies for other communications. So sometimes pilots have a hard time even in a busy air traffic control tower or a busy section of airspace, just trying to get their request in or their comments in that they need to talk to the controller about. So using this capability for routine communications frees up the airspace or the radio communications frequencies for other issues that pilots have. So it's a good thing, yeah.
Yeah, thank you, Lene. Next question. We're going to have a video clip on screen for this. Can you talk about how Seattle and Boeing Field separate aircraft on North Flow? This is for Sean, please.
Thanks, Grady. Yeah, as you can see, once we get the video started here, the aircraft in the pink are Boeing arrivals coming in from the west. They're actually below the aircraft on the downwind for the the west side of the airport. We'll descend those aircraft above the traffic that is landing at SeaTac, the blue aircraft that are going straight into the Seattle runways there. We'll vector the aircraft for final to land at Boeing Field and descend them below the arrivals for the east side of the airspace. Again, it gets back to something that Jeremy's already talked about, the flight paths of the aircraft. And when you adjust one in the congested airspace that we work with here in the Puget Sound area, you are going to affect the flight paths of other aircraft. In these instances, the controllers use vertical separation. And then once they get laterally separated from the Seattle final, they'll go ahead and just send them down into Boeing Field.
All right, thank you for that. Next question, and Sean, I think this is a good question for you as well. Some airports alternate the direction they take off and land to balance the noise impact. Can SEA do that?
And again, something that Jeremy hit on a little bit earlier, what we try to do and what we want to do is take off and land into the wind. It provides efficiency for the aircraft, extra lift, and just provides a safer environment for the aircraft to operate in. Once we take that away, if we're trying to land or depart with a tailwind, it does take some efficiency away from the aircraft, and I'll defer to my airline partners to describe exactly how that would affect their operations.
All right, Tony, could you add something there?
Yeah, that's a really good question. So aircraft perform much better when they are off and landing right into the wind, and it's really down to basic physics. So by flying into the wind directly, the lift that is generated by the wings can be enhanced. And if we do not have that takeoff into the wind, if we have a tailwind, for example, we can have a significant loss of performance, and we may not be able to carry as much payload. For example, customers and cargo and mail and everything else that we carry on board our airplanes. So we want to carry everybody that purchased a ticket for all of our flights, and so that's the reason why the going into the wind is very important.
All right, thank you, Tony. Next question. If there's not a noise monitor close to my house, how does the airport know how loud it is? Ryan, please help us with this. Ryan from SEA.
Yeah, thanks, Grady. We know about how much sound a specific airplane creates when it flies over a specific point at a given altitude. So even if we don't have a noise monitor there, we can build a simulation of thousands of sound events or those airplanes passing over that point in a year, and then see the results with the computer noise model approved by the FAA, which is the Aviation Environmental Design Tool, or AEDT. Here at SCA, we have 24 permanent noise monitors located throughout the Puget Sound area, and those noise monitors capture data, and they feed into our NOMS, or Noise and Operations Management System. And then SCA is also conducting its Part 150 noise study, and that will include a review of SCA's noise monitors and see if any need to be moved or new ones need to be added.
All right, thank you, Ryan. The next question, why is there a concentration of flight paths on the west side of the airport, particularly over Vashon Island? When we consider the airport's, SEA airport's inevitable growth and the need for expansion, need to maintain so when we consider the airport's inevitable growth and the need to maintain its level of safety and efficiency, I think we'll eventually see an expansion of satellite-based procedures in the Puget Sound area. So while now through the PBM procedures on the west side of the airport do result in those greater concentration of flight paths. For the remaining patterns surrounding SEA and the greater Puget Sound region, over time, due to the growth and the improved technology, those procedures and those innovations are more likely to be implemented. And Sean, what's your perspective on this?
Yeah, I think it goes back to we build the procedures for landing and departing an airport based on the runway geometry and the runway configuration we have here at SeaTac. So from the runway out, we're building finals that are set up straight in to land anywhere from 5 to 25 miles into SeaTac. Then the arrival procedures for our downwinds, which is in a south flow, how aircraft will be flying over Vashon or the east side of the airport. We try to keep the downwinds about 5 miles away from the final or airport as they proceed north, and it's just, again, it goes back to the geometry of the runways, trying to get aircraft set up for or configured for a good landing there. One of the other big issues we have in the Seattle area is just the prevailing wind from the southwest. The final controller at Seattle TRACON is blending aircraft from the east side of the airport and the west side of the airport. So giving them a standard or predictable path that those aircraft fly on helps them be more safe and efficient as they blend the aircraft from either side of the funnel.
Thank you, Sean. And Lene, what's your perspective on this?
I think the question may have a little bit to do with some of the, excuse me, the using our GPS procedures that are in place on the west side. And so those have kind of narrowed down the path of flights over Vashon. And I think in the video, Sean was maybe pointing out some of that because we're using waypoints, which are latitude, longitude points in space to fly an arrival procedure. That's an optimized descent profile, it's called. So we're trying to keep the throttles back to reduce fuel burn and then have kind of a nice continuous descent towards the airport. I think we're seeing that a lot of places. A lot of folks have heard of Next Gen, and that's part of using satellite-based navigation that aircraft are equipped with to be able to fly more precise patterns and more fuel-efficient flight paths. So we support that. We support efficiency and predictability in the flights, and I think that's maybe what that was touching at. So just that's our perspective on it.
All right. Thank you, Lene.
Oh, I'm sorry, Greg.
Sean? Yeah, back over to you.
I just wanted to add, I think Lene hit on something there. Just the predictability of that path on the west side of the airport there, as our departures cross underneath the arrival path and then are climbed up once they get to the west side of the arrival path. That predictability and knowing where those aircraft are going to be lets us be a lot more safe and efficient as we transition those aircraft up to the higher altitudes as they depart the Seattle area.
All right, thank you, Sean. So this is why we have a diverse panel here. On that question, I clearly stumbled out of the starting gate, but fortunately, Sean and Lene brought much greater insight to the question. So thank you. Next question, why are aircraft allowed to operate 24 hours a day? This questioner says they should not operate between 1 a.m. and 5:30 a.m. so we can all sleep. I'll start this answer first. The FAA, neither the FAA nor the airport have the authority to regulate the time of day or the number of flights or the type of equipment unless there was a curfew in place. That would be in place before the Airport Noise and Capacity Act went into effect, which was back in 1990. So Tom, share with us about the late night noise limitation program at SEA.
Yeah, thanks, Grady. When START first formed back in 2018, and we started to hear from community members as to what their core complaints were about aircraft night flights, those loudest aircraft in the wee hours of the morning were the number one complaint that we heard from folks. Is there anything that can possibly be done about those aircraft? And within our limited authority as an airport, so we created this late night noise limitation program utilizing our noise monitoring system. Between the hours of midnight and 5, we assess the noise levels of takeoffs and landings for every carrier that operates during those hours, and we have set thresholds. And at any operation that exceeds those thresholds is included in our data, and then we reach out to those carriers quarterly and give them the list of operations that may have exceeded a noise threshold. And then our major ask in that program is there a schedule change that you could possibly take to lessen your operations during those hours, or is there a quieter aircraft that you could introduce into the airport? And we've had a few successes with that program within our limited authority. Oftentimes that the carriers that we talk to the most are, of course, those cargo carriers that may operate during the late night hours. They are often our loudest carriers. So we are in front of those carriers often. And just from the perspective of the noise programs office, it's a great opportunity to get the noise conversation in front of those staff members, particularly those cargo carriers, and let them know that we do have a program and we are monitoring those carriers.
All right, and I could just add to that with the cargo operations to Taipei and Seoul and Shanghai, oftentimes they need to depart Seattle when they do because they have their connecting banks or connecting complexes in their own hubs in Asia. So it's a global perspective that they have. Now, Lene, Alaska Airlines does a fair amount of point-to-point operations in addition to hub and spoke. Can you share your insight for Alaska and its network and its impact on late night operations?
Yeah, thank you. We typically will schedule flights based on the demand. So whether that's our cargo operations, which we do have a freighter operation, and or our passenger aircraft, which it could be our mainline with our Alaska Airlines, our regionals, which is Horizon Airline, and also SkyWest that does some flying for us too. And some of that is connecting flights. Folks will maybe want to come from Alaska or some smaller communities into Seattle as a hub, and then connect on a flight going to the East Coast or to the islands. And so some of those flights that are maybe really early in the morning could be connecting to traffic that's going to then go a little bit later in the morning to somewhere else. But we need to have those connections to be able to serve the folks that want to go the places we fly that don't necessarily live in the Seattle or Puget Sound region. Sometimes the later night flights, we don't schedule really very many flights during those late night hours, but sometimes flights do get delayed and will creep into really late night hours depending on what's happening. If you have a snowstorm on the East Coast or a hurricane in Florida, or just foggy weather in San Francisco, or even Seattle has our share of poor weather conditions too, but that can affect the inbound flights coming from another place may end up getting more and more delayed coming into Seattle, and then maybe those flights we're going to turn around and go somewhere else. So a lot of it is dependent on the weather too, and not just the schedule. But bottom line, we schedule flights when we do, first based on demand, and then we start looking at airplanes and pilots and flight attendants and crews and all that to kind of finalize those times.
Thank you, Lene. And Tony, with Delta Airlines being a member of the SkyTeam Alliance, the global alliance, with that hub in Seoul, in addition to Paris and all of Delta's hubs, what are the complexities that your airline deals with that can result in either very early morning departures or late night departures and arrivals?
Yeah, Grady, that's a really good question. We do at Delta, we want to be good corporate citizens, and we generally fly, as Lene said, also when there's a customer demand. So most of our flights do not leave before 6 a.m. or later than midnight. However, as it is a complex operation, and there might be some times when flights are delayed at their origin due to maybe it's a maintenance issue or something that's preventing them from departing on time. But obviously, we want to get that aircraft moving as soon as possible, and that might require a really late arrival, especially if it's been delayed in New York for weather or maintenance issue. Regarding the hubs, we have a global operation, and we connect our customers from all over the world. Directly from Seattle to Europe, like in London or Paris, or we go to Asia and we fly to Tokyo and Taipei. So as you can probably imagine, schedules are, very intricate, and we're working within a framework that meets the needs of our customers and local community, as well as any regulatory requirements on every side. So we try to balance all those needs as best as we can, and create a schedule that works for everyone.
Mm-hmm. Thanks, Tony. And yeah, given the complexity of it on a global basis, there are trade-offs that you have to analyze and decide. So thanks for that. The next question is, how often has the FAA rerouted or changed plans based on public complaints? I'll start with that. FAA continually monitors the effect of proposed procedures on communities, and those proposed procedures, they must undergo environmental analyses and safety reviews prior to approval and implementation. Sean, what can you add here?
I want to say, while our overarching goals, working air traffic in the Puget Sound area is to provide safety and efficiency for our customers. We want to do that also with being good neighbors in mind. be good stewards of the airspace. I think the 99% adherence that Mr. Little spoke about in the initial part of the video, of us adhering to our noise procedures in the airspace, speak to our commitment to doing that and being good neighbors and working the air traffic in the Puget Sound area.
Thank you, Sean. Really good point. The next question we have is, why is NextGen still in place? That may have a reference, be a reference to the Hawk's arrival also, perhaps. Jeremy, help us with this.
Yes, there's a lot of history behind, that question, Grady. In 2003, Congress mandated that the FAA upgrade the national airspace system. That was kind of the inception of NextGen at that point. One of the first things to do was to upgrade from ground-based nav aids to satellite navigation, GPS, or RNAV, as we've been speaking about. The reason that NextGen is still around is that work is not complete. It's been a very slow and tedious process working through it. I mean, there are many communities, Seattle being one of them, and as far as aviation and with these routes of flight. On the west side, we have the STARS and the RNAV approaches that are, as Sean spoke to in Lene, they're much more accurate, and they're much safer and much more efficient use of the airspace. But if you look at the east side of the airport, they're still using traditional ground-based navigation there, where the aircraft will come into a certain point and then the controller is going to issue radar vectors. Those are much more subject to winds and different things like that gives you a much more scattered type of route of flight and less predictable, which again creates less efficiency as far as use of the airspace. And so that's exactly why NextGen is still around. We've still got work to do. We've got to get all of the procedures upgraded and optimized. And in fact, the FAA Reauthorization Act of 2024 requires that the FAA operationalize NextGen by the end of next year, 2025.
Indeed, it does. Thank you, Jeremy. The next question. What is the status of aircraft using environmentally sustainable fuel and efforts to mitigate noise and air pollution in areas with high volumes of air traffic? So what's the status of aircraft using environmentally sustainable fuel and efforts to mitigate noise and air pollution in areas with high volumes of air traffic? Sarah, could you help us out with this?
Yes, thank you, Grady. So as you've heard kind of throughout this conversation, the production and utilization of sustainable aviation fuel also requires the collaboration with FAA, our airline partners, the airport, as well as many others in the industry. And at SCA, we have been working with the SAF producers and other transportation, conveyance distributors of SAF to figure out how we can bring sustainable aviation fuel to our facility at SCA. The markets are still developing, and the use also depends on the cost, the availability, what incentives are available, as well as some of the regulations for use. And so we at SCA are continuing to actively support SAF policy in Washington state and at a national level. And over the past decade, we've also conducted numerous studies, including SAF feedstock availability in our state, and what are the regional infrastructure needs to bring SAF to our region. Thank you.
Yeah, thank you, Sarah. Lene, what's the perspective of Alaska Airlines with SAF?
For sustainable aviation fuels, we know that it's critical to meet our sustainability goals in the future, and we do partner with the Port of Seattle, with other airports. Again, it's, as Sarah was saying, it's about getting it available at the airports that we serve and at our hubs. Right now, we probably fly not even quite 1% of our flights are using sustainable aviation fuels, but it's proven it's about just getting it, the production and the availability of it at our hub airports. So that's definitely a goal we're working with the port closely on as well.
Thank you, Lene. And our next question here is, can I get a complete list of all the questions asked? and a list of questions that we don't have available, but there will be a recording of the entire event, and you can find that at any time after this session on FAA's YouTube channel. So we encourage you to check out FAA's YouTube channel. All right, next question. So when late night or middle of the night south flow Hawks arrivals are cleared to a visual approach while over the South Sound, their avionics continue to fly Hawks laterally with extreme precision. But any pretense of observing the altitude directives at the NETS, Key West, or Vashon waypoints is absent. If all of these arrivals are exactly tracing Hawks laterally, what can be done to make sure they also follow its altitude directives, especially in the middle of the night? So, Sean, what's your take on this? And if I need to reread it, I certainly can.
No, I think I have it. Thanks, Grady. No, again, in the middle of the night and when traffic volumes are down, there isn't as much interaction between aircraft arriving from the west side of the airport to the east side of the airport. So the need to extend an aircraft on the downwind on the west side, or have them maintain altitudes to fly an extended downwind or extended final, we can actually reduce the flying miles of the aircraft, issue the visual clearance to the pilot, and at that point, it takes away the altitude restrictions on the procedure and transfers that requirement to the pilot. And then in that, the pilot is going to take control of the aircraft and set them up for a safe, stabilized approach. And again, we're reducing the flying miles that the aircraft has to fly. And in most cases, they'll remain over Elliott Bay and over the water as they turn final for Seattle.
All right, thank you. And Sean, just a question. I'm not an air traffic controller. I think I said Key West, but I meant, is it pronounced Quest? Kwest? Quest?
Yes, it is. NETS,
Right.
Quest, Vashon. Yes.
Okay, excellent. Thanks for your help on that.
Yeah, welcome.
So next question is about optimized profile descent, or OPD. So before OPD, optimized profile descent, was implemented around 2015 as part of Greener Skies Next Gen, the west side downwind south flow arrivals, they would stay higher longer when the downwind U-turn point was being pushed further and further north. There's no reason to get low prematurely if you need to fly to Linwood and back before landing. The net result is that descent profiles were actually more optimized before OPD was implemented. The question is, how can we get back to more truly optimized descent profiles? Jeremy, what's your perspective on this one?
Yeah, so an optimized profile descent arrival or approach, as we kind of mentioned, is designed using precise combination of a descent rate, altitude, and a distance to fly. I believe Lene kind of referenced it earlier. Essentially, the pilot's able to set, the engine settings of the aircraft at a certain point and almost just leave it where it's at because it's following those exact parameters that are designed in those descents. If there's nobody else in line to land or the weather is perfect, these are easy. We don't have to touch them as air traffic controllers. They can fly these profiles. We issue the clearances as needed, and they can fly it all the way down to the runway. That being said, if we have more traffic or additional traffic that they need to be sequenced with, if, for example, if there's a space where we can get an aircraft in sooner, or in the event of inclement weather, when we have thunderstorms or those type of things that the pilots or the aircraft cannot or do not want to fly through, we're going to have to do something different with them. We've got to issue those speeds. We've got to issue those altitudes and kind of take them out of that optimized profile descent. And so it's not always easy to use those. And they're not always coming in at the exact same spot. We're shooting for 5 to 25 miles to get them established on the final, but that's all dependent on the traffic that's coming in, the volume of traffic, and then also the weather has a big thing in that. In addition, the altitudes that the pilots have to maintain are to remain clear of traffic coming and going from Boeing Field, Payne Field, McCord, Renton, and other airports that are in the sound area.
All right. Thank you very much, Jeremy. Our next question is, this participant would like to understand how FAA and SEA are looking at the outlook from Seattle-Tacoma International Airport, knowing that air travel is only going to increase. Sarah, I think this may touch on a topic that's not directly related to what we're doing this evening, perhaps the Sustainable Airport Master Plan and the near-term projects.
Yeah, thank you,
Could you help us
Grady.
with that? Yeah.
Yep. Yeah, so, well, the FAA, has a program of the master plan, which is kind of similar to what a city does for their comprehensive planning, looking at what is the forecasted demand or needs for the future. And that is the master planning process for airports. So CTAC has undergone this process with FAA. We completed the planning efforts in 2017, 2018, and now are in the environmental review process of that. And the Sustainable Airport Master Plan near-term projects that we developed out of the planning process identified 31 proposed projects to meet this forecasted projected demand at SCA. And this includes 19 new gates, some cargo facilities, some airfield improvements, a variety of projects as we anticipate this forecasted demand, and that will improve safety and efficiency at SCA. And so that is now the environmental review process at the federal level under NEPA, and then we'll be moving into the state SEPA, State Environmental Policy Act. Sorry, I was doing an acronym over the next year. Thank you.
All right, thank you, Sarah. I appreciate your help. So our next question is a participant who asked, I am a resident of Des Moines, directly under SEA's runway 34 left approach. I would like to become more involved in the community. So Tom, how would this person, who may very well be a very close neighbor of mine, but I don't know who it is, I don't know who asked, how would they get involved? What would your approach be?
Yeah, thanks. Well, to start off, in addition to contacting our office through the various avenues available to find out more information about aircraft flight paths and what's typical, there are a couple of additional ways. One is I'd like to highlight our Part 150 noise and land use compatibility study, which kicked off earlier this year with 3 workshops in June. This is a multi-year study that will evaluate existing and potential new noise abatement measures at the airport, assess how aircraft are operating, if there's any ways that aircraft could possibly operate quieter. Many ways can be explored through the Part 150 process, and there are and will be many opportunities for the community to provide input to the Part 150 noise study. We anticipate that we will go back out for more meetings in 2025, public meetings. And I would like to highlight, since we're here tonight, we do have our study website that's available with all the study materials to date and a study schedule, as well as a way to leave a comment to the study team. And that website is scapart150.com. scapart150.com. That's our study website. So comments, leave comments there to the study team. All those comments become part of the study record as well. So I want to highlight that. And lastly, I just want to talk about our, as we've talked about previously, our SCA Stakeholder Advisory Roundtable, which meets bi-monthly. Our next meeting will be in December. Is a great way for community members to monitor what's happening at the airport, operational updates, noise updates, very timely updates that happen regularly at the start meetings. There's also opportunities to leave public comments at those public meetings as well. So there's a few ways to get involved, for sure.
Thank you, Tom. I appreciate that. The next question, are there any changes to operations or runway use at SEA that may be noticeable to the local community? Tom, what are your thoughts on this?
Sure. And this is something we talk about at START quite a bit. In fact, we've seen in the opening, we've seen what's typical, the runways that are used for landings, the runways that are used for takeoffs. But often if a runway is closed for a maintenance reason, and oftentimes it happens during the nighttime hours when regular maintenance needs to occur on one of the runways, then you might see the runways used a little bit differently. We have a voluntary agreement with the FAA to limit the use of the third runway between midnight and 5. It's been a great success, but there are many nights that, for example, this past summer, we had the east runway, our longest runway, was closed many nights per week because of a couple of construction projects that are now complete. At least on the airfield side, they're complete. But that changed how runway use is affected. So that's definitely something that folks notice. They notice when there's extra operations on the third runway during those hours. And again, it's sometimes good to hear that feedback, because I know that when things go back to normal, that third runway won't be used much at night, and that will be an improvement. So, so those are some factors that can create differences.
Thank you very much, Tom. So next question, the participants worried about overworked and stressed out air traffic controllers and ask, is FAA adding more controllers? And yes, the FAA, we are adding more controllers. It's a very aggressive hiring process that we've established to increase our controller workforce. In 2023, just to go back a little ways, we did hire 1,500 controllers. That following year, 2024, this year, we've hired more than 1,800 more controllers. Our goal for next year is to hire 2,000 controllers. We have a year-round hiring opportunity for experienced controllers, and we also target military and private industry for this controller pool. So thank you for that question. Next question is, can you share FAA's continuing efforts to further evolve Boeing Field VFR, visual flight rules, arrival and departure procedures to improve safety and use? Sean, help us out with this one.
Thanks, Grady. Yeah, in 2021, there were 2 VFR routes that were removed from BFI to alleviate TCAS events. And TCAS is Terminal Collision Avoidance System that most aircraft have nowadays. All air carriers have it. Basically, it is a onboard equipment that will advise the pilots of through an algorithm, the way that the computer sees the other aircraft around them, based on climb or descent angle of attack. Basically, the TCAS equipment will advise the pilot in command of what the algorithm deems a pending collision based on the climb and descent of the 2 aircraft and how they're approaching each other. Again, with the condensed airspace that we have, especially Boeing Field as it operates below the Seattle final, in a south flow where we are. It's our main configuration here. They did remove those 2 routes just to alleviate some of those TCAS advisories. Again, I'll defer in a minute to my airline partners, and maybe they can explain the TCAS maneuvers or whatever a little bit better. But they also introduced 2 new routes to help alleviate that and work the VFR aircraft into and out of Boeing. And again, the FAA continues to monitor and assess the routes in and out of Boeing, again, for safety and also to be good neighbors as those aircraft transition into and out of Boeing.
All right, thanks, Sean. Tony, I think Sean was thinking maybe you could help out a little bit more on this from the TCAS perspective.
Yeah, so TCAS is an instrument on board the aircraft, and as Sean mentioned, alerts our pilots if it detects another aircraft in close proximity. So, and when it does that, it will give a what we call a resolution advisory, and it will give direction to the pilots to either climb or descend in order to avoid the other aircraft. And if the other aircraft also has TCAS, that system will actually talk and has an algorithm that it knows what the other system is going to predict, and it will predict the opposite way so that those aircraft can continue to be separated properly.
Thank you, Tony. And our next question, air traffic over Vashon is loud and heard inside, and helicopters shake windows. When will FAA provide sound benefits to residents? Tom, help us out with this one.
Sure. Well, from the airport perspective, I again want to mention the Part 150 noise study for certain as a way to that we are assessing aircraft noise and hopefully lessening noise in the future. But our role in the Noise Programs Office is to really be responsive to community noise concerns and provide complete and accurate information about exactly what's happening over their heads. With aircraft, we have a noise monitoring system, an aircraft noise monitoring and flight tracking system that is very accurate and precise. So we're able to give folks the best information about what's going on and help explain why aircraft are there. And I do want to emphasize our programs that encourage airlines to bring in those quietest, most modern aircraft into SCA, such as our Fly Quiet program, which recognizes the 3 airlines that have done the best in various categories, noise being obviously the number 1, noise levels being the number 1 aspect of that award. And the other end of that is the late night noise limitation program, again, encouraging airlines to bring in the most modern and quiet aircraft available. And lastly, I'll say with this question that I will point folks towards an FAA initiative, which is the noise policy review that's underway, looking at, and this kind of points back to Part 150 in a way, the DNL noise metric and evaluating the DNL noise metric. Is it the proper metric going forward? Is 65 the proper level? And so the FAA has undertaken this to their, undertaken an effort to look at that and assess it. So I think that has a lot of influence on future with noise mitigation.
All right, thank you, Tom. And you're absolutely right that some of the incentive programs or the recognition programs that you have, you are getting results, positive results, and many of these things. You also mentioned START, the community roundtable. That's a really great venue for discussing proposals and ways to incentivize the carriers to the benefit of the residents in the surrounding communities. So yeah, so hats off to you for those initiatives and the successes. All right, next question. Our community has been suffering from constant aircraft noise from southbound arrivals since 2016. What is the FAA doing about that? Sean, help us out with this.
Thanks, Grady. Again, the current landing routes at SeaTac have been in place for many years, and it goes back to something we talked about a little bit earlier. It's just that the geometry of the runways. Our final approach course is going to be based on the geometry of the runway, lined up straight for the landing runway, and again, putting the aircraft in a position for a safe, stabilized approach. But again, with providing safety and efficiency for the aircraft that are transitioning into and out of Seattle, we're committed to addressing the community concerns and working collaboratively with our stakeholders.
Thank you, Sean. And you mentioned stabilized approaches. Lene, I understand that you've got your licensed commercial pilot and instrument rated. Help us and the viewers understand what is meant by a stabilized approach.
Sure. It's just that when we're coming into the airport, we want to be aligned with the runway. I think Sean has pointed out a few times about like why the runways are oriented the way they are. And so we want to be, lined up with the runway center line. We want to be on the right speed and the descent angle. And then we also want to have our landing gear and flaps set properly by the time we're 1,000 feet above the runway. So it's about getting all those things right on target so we have a nice smooth transition from flying to landing right in the touchdown zone.
All right. Thank you, Lene.
You're welcome.
Sean, in terms of so if the approach something happens and the pilots execute a missed approach, how often does that happen at SEA? Is it very frequent or very rare?
I would say percentage of operations that we have, we would consider that a rare occurrence. But again, for the air traffic controllers and the pilots that are involved, it is something that they've practiced and done many times. So it is a planned and safe maneuver where the air traffic controller will issue a heading and an altitude to the aircraft to take them back around to get set up again for another safe, stabilized approach.
So depending at the altitude at which the missed approach was executed and the routing of the aircraft, so some of the residents around the airport could experience an aircraft that's flying a little lower than they would expect on a routing that's not common. But that would be because an aircraft failed to clear, arriving before the approaching aircraft, failed to clear the active runway in time, or any other number of reasons that the pilot chose to execute that missed approach. But that's something for residents to keep in mind. If you see an aircraft that's on a little bit different path and perhaps a little lower, and they're trying to rejoin that approach sequencing, so they're vectored into that. So residents of Vashon Island might also experience that as well, based on the missed approach procedures. So just wanted to point that out, and thank you, Sean and Lene, for that. All right, next question. Small propeller aircraft unmuffled at low altitudes are the nuisance above us. What is the FAA doing to make these aircraft quieter or make them fly higher? Jeremy, what's your perspective on this?
So many times the smaller propeller-driven aircraft that you're seeing kind of loitering in areas are going to be flight training. People that are learning how to fly, learning the basic maneuvers of flight, that type of thing, so then they can move on and become airline pilots themselves, and fill that the voids that are there. Part of the flight training, they don't necessarily have to be talking to air traffic control. What we do is for busier airports, for Seattle or like Seattle, for example, is there's a controlled airspace that's designed around it. We start at the runway again, as we do with almost anything, as we keep talking about tonight. It'll start at the runway from the ground to a certain altitude, and then as it gets further out, the airspace is still designed to protect the aircraft inbound to that airport, but there will be basically what are called shelves. And so the controlled airspace won't go down to the surface. It'll start, say, at 4,000 feet and then go up to 10,000 feet, for example. Many times the aircraft want to operate in those areas below that shelf. And when they're in there, again, they don't have to be talking to air traffic control. And so this kind of limits them, though, from climbing into that airspace. They need permission to do so. Many times they're not going to be allowed to for the safety of flight. Again, it will cause them to get in close proximity to the larger aircraft operating in and out of Seattle or any other busier airports. And so, lost my train of thought there. But additionally, with the aircraft themselves, the small aircraft, most of the noise is coming off of the propeller of those aircraft. So if you put a muffler on there, it's going to decrease the performance of the aircraft and, hinder that, but it's not going to muffle that noise at all. And so, plus there's also equipment regulations that the FAA has on changes that you can make to an aircraft. It's not exactly like your car where you can add different things as you see fit. There's regulations to help maintain safety when they make changes to their aircraft.
All right, thank you, Jeremy. I've got another question for you. This participant asked says that they live in Lake Forest Park, north of Seattle, and during the most common flight pattern, about 70% of the time, they estimate, they get a large amount of arrivals flying over residential areas. And sometimes less than 60 seconds apart at around 5,000 feet, they estimate. As this participant understands it, this is due to the need for east and west arrivals being zippered together in a single glide slope into SEA. And they say that could be mitigated by implementing a satellite guided path for east side planes, like there is for west side planes. How could you make that happen? And I can reread that if you'd like, Jeremy.
I think I get the gist there for sure. Thank you, Grady.
Okay, sure.
As we consider the airport's inevitable growth, we do need to maintain that level of safety, like we've talked about, and the level of efficiency. And when we refer to efficiency in this manner, we're talking about the best use of a congested airspace, maximizing that use without sacrificing efficiency, without sacrificing safety. And so there is a need for the GPS approach, as we've talked about. It's much more accurate. It's more predictable, and there's a desire for that for sure. But even if these procedures are designed, as we've talked about, there's still the factor of we have to keep them separated. In order to do so, many times we can't stick exactly to these procedures because we need to sequence them with other aircraft. The other factor that we've talked about several times as well would be weather. If there's weather in the area, they're going to need to use a different flight path to be able to get around that weather safely, and then again be sequenced in with the traffic into the airport.
And we all know about convergence zones in the Puget Sound region. So yes, the weather can certainly complicate things. The next question, we live 5 minutes from the airport, and some nights the sound of takeoffs lasts longer and it's louder. What impacts the amount of time we hear noises from aircraft? Does the time of year or the weather impact noise traveling further? And could it be due to different kinds of aircraft operating in the nighttime hours? So Tom, can you help us with this one?
Yeah, thanks. That's a very good question. Atmospheric conditions definitely do affect the propagation of noise, particularly if you are east or west, not directly under that flight path. You will hear aircraft differently based on temperature. Aircraft noise tends to travel further in the colder temperatures, less humidity. Temperature inversions definitely intensify noise closer to the ground during those cooler mornings that we're experiencing now. That those temperature inversions do cause that noise to spread. Wind direction causes noise to spread. I know just from experience in our noise office, we get more calls about this type of noise during the cooler winter months of the year from places like Burien and Normandy Park and Des Moines west of the main flight paths. For those reasons, I do believe, because of the colder temps. And as far as nighttime aircraft, yes, some of those loudest aircraft that do operate at our airport operate during the nighttime, and that might be a 747. There aren't many of them at our airport, maybe 3 takeoffs a day of 747s, but they're often during the nighttime hours with some of those cargo carriers. So aircraft types can definitely play a role.
That's a really good question and a great answer. Thank you, Tom. So next question, when analyzing the regional capacity of Seattle-Tacoma International Airport, which other surrounding airports would serve as optimal candidates for expansion, considering projected population growth trends? Sarah, bring us up to speed on that topic.
Yes, I can do that. So when we look at forecasted growth, like in our Sustainable Airport Master Plan, we're looking at specifically at SCA, at SeaTac International Airport. However, the Puget Sound Regional Council has looked at what is the forecasted demand by 2050. And with that, the Washington State Department of Transportation has a working group. It's called the Commercial Aviation Working Group. You might also hear it referred to as COG. And the goal of this working group is to recommend a workable solution to meet these long-term travel needs for our region. And I know that they're looking at what this could look like beyond aviation. Would it be rail as well? So it is going to be a variety of travel options as they look at what the forecasted demand that we're expected to see.
All right, thank you very much, Sarah. Next question. I'll take the first stab at it, and then I'm hoping that some of you can join in. Question is, have you guys ever changed a procedure you put in place when the community was upset about it? And thanks for that question. I know it may seem frustrating and seem like it's impossible to change something that you find annoying. We do engage with local communities across the country, all across the country, to assess the ideas and the suggestions and to help relieve airport noise. It can be a real challenge. And working on aviation noise issues, it's best when there's broad stakeholder representation to ensure that all communities and concerns are represented, not just 1 or 2 communities who then may propose to move the noise to other communities that aren't represented there. So START's a good example of the type of engagement where a number of communities immediately adjacent to SEA are brought together to exchange ideas, proposals, experiences, concerns. So START and other community roundtables across the country, they're addressing these concerns. They're developing unique approaches for incentives for air carriers, and it's an ongoing process. But I tell you, when people can get together respectfully and put their creative thinking into play, things can be accomplished and things can get better. We encourage the airport and the surrounding communities to continue to maintain that open dialogue and reach community consensus when it's possible. So, Tom, what's your perspective on this? You have a lot of experience with START for sure. What is your take?
Yeah, and the START roundtable has been a great avenue opened up with community members from each of the 6 cities that are members, as well as those that are giving public comment. It's really opened up a lot of different topics at START. In 2022, we began a ground noise study, which looked at the various sources of noise coming from the ground, just as an example. And out of that study has grown many new initiatives added to our airline record, encouraging limiting the use of reverse thrust. We found that continuous taxi to takeoff was very effective at limiting the noise from takeoffs. Basically, having that aircraft when operations are low to not stop as it finishes its taxi and goes right into takeoff, and goes to full power further down the runway, which does get that noise source further away from the communities off the airport. Single engine taxi is a great opportunity. Another avenue that we've encouraged through START, and our airline partners, Alaska and Delta, have been great help with that one, as well as all of these initiatives. So START's been a great avenue. So I'll continue to push for START and these various ways that we can improve noise wherever we can.
Thank you very much, Tom. Lene, would you share your perspective with us?
Yes, we do participate in airport community roundtables at several airports, and also on like technical working groups for Part 150 studies, and work with FAA with, like I think I mentioned previously, if there's procedure design to help fly that in the simulator and see if it works effectively for the aircraft that'll be flying it. As I'm thinking about this, I think when they were talking about procedures, this might be about flight procedures. I can think of one example not too long ago in San Diego. There was a departure procedure that through their Part 150 study, they made really a minor adjustment to it. And so that was kind of listening to what the community was interested in. I think that's where you get back to what's the way we can collaboratively hear what the concern is, and then is there anything we can do with that in the complex airspace we're working in. So I think that's, as Tom was mentioning, just hearing where the concerns are, where the challenges are, and then if there is anything we can do to mitigate that, we're partners with that.
Right. Thank you, Lene. Next question is, how could you widen the arrivals flight path so that many flights do not fly over residential areas? We've had some questions along similar lines here. Sean, could you address this, please?
Yeah, again, it goes back to the geometry of the runways and what runway the aircraft are lining up for. But again, the arrival flight paths, because of the airport geometry separation rules that the air traffic controllers use, need to be narrow and a very defined path straight out from the runway. And again, as stated earlier, as we get busier, the traffic volume dictates that that final may be extended out away from the landing threshold. Again, we're shooting from anywhere from 5 to 25 miles, prevailing winds, the volume of aircraft. We talked about it a little bit earlier. In most cases, we're shooting for 3 miles between successive arriving aircraft. But again, prevailing winds, the volume of aircraft will dictate that we have to use 5 miles between aircraft as they turn on 17 to 20 miles away from the airport, just so as they transition from different phases of flight down the final, that 5 miles will collapse down into 3. In certain instances, we can use even 2.5 miles of separation. But again, it really goes back to the geometry of the runways that we're landing on and the volume of traffic that would dictate our arrival path. When we look at the departure path of the aircraft, again, we've spoken about it a little bit. It's just the predictability of where that departure aircraft is going to be. And when we start trying to move those or disperse those flight paths, we very quickly get into or affect the flight paths of other arriving aircraft or other departing aircraft from our satellite airports around the area. So the Puget Sound area does have a very congested and just compact area. So as we move flight paths or even look at that, we always have to take into account how that's going to affect the other flight paths that are surrounding it for the other airports and even the other aircraft that are landing or departing the Seattle airport.
All right, good point, Sean. Thank you. And Jeremy, question for you. What's involved in changing flight paths?
So I think I spoke to it earlier just very briefly, but all procedures must undergo a safety analysis to ensure that they meet certain safety criteria. Some of that criteria has to do with the aircraft itself, performance of the aircraft, passengers on board. When they're considering routes of flight, they're looking at how much of a bank or a turn is the aircraft making, and things like that. Additionally, with that safety criteria, they're looking at all of the other procedures in that airspace. Is it going to be separated from other aircraft operating in and out of the airspace there? Not just to the one airport, but again, all of the airports that are in that area. Additionally, these changes must undergo an environmental analysis under NEPA, which is the National Environmental Policy Act. That in itself can be a long process just to get a procedure put into place. Any changes that must be viewed in relation to other routes, like I mentioned, to ensure that we're separating them from other procedures. I think that's one of the biggest things that we're looking at, is to ensure that we are operating safely within the airspace, that this route is going to be changed.
Great, thank you, Jeremy. So here's an interesting question. I'll take this one. What's the agency doing to move away from leaded aviation fuel? The FAA, we partner with the aviation community, and we've launched the EAGLE initiative. That's a result of a congressionally mandated report, and it's from the National Academies. And the EAGLE's team goal is to eliminate leaded aviation fuel in piston engine aircraft safely by the end of 2030. In addition, there are airport sponsors such as Centennial in Colorado that are developing incentives and cost-effective measures to make unleaded aviation fuel more attractive to general aviation users in particular. All right. Next question, how will the work that the FAA is doing tie into the work of the Commercial Aviation Work Group? So Sarah, I think you've addressed this before, but perhaps come back to this. How will the work that the FAA is doing tie into the work of the Commercial Aviation Work Group?
Yeah, so the Commercial Aviation Working Group is really trying to figure out how to best manage the state's long-term transportation and aviation needs. And so, especially if it's related to aviation, they'll be having discussions with the FAA as to what that looks like. And then also, we have invited the COG to present at our START roundtable this past summer. And our goal is to have continued dialogue and have COG push for to play a greater role in identifying where the aviation demand can be met. And I just also want to note, they are taking inputs, and they are working on filling their working group. And so if there is interest, I'm putting a plug out there for them, please look that up because they are looking for feedback.
All right, thank you very much, Sarah. Next question, what technologies are available in the future to reduce airplane noise? Well, first I can cover a few key points here. FAA, we've got the CLEAN program, that's C-L-E-E-N program. That's for continuous lower energy emissions and noise program. It's the FAA's principal environmental effort. And then we also have the recent CHIPS and Science Act that included a new cleaner, quieter airplane program for NASA, and it directed NASA to develop new technologies to reduce emissions and noise from aircraft, including a target of achieving net zero emissions by 2050. And then finally, there's the Inflation Reduction Act. And that includes a new tax credit and establishes new grant programs to accelerate the deployment of sustainable aviation fuels, which we talked about earlier, and low emissions technologies. Tony, what can you add to this? Technologies available in the future to reduce airplane noise.
Yeah, it's a really good question. You know, the engine and airplane technology has really improved greatly over even the past 10 to 15 years. And, we've established sustainability goals, and we've been investing in our own fleet renewal program, which can really be seen in Seattle actually quite a bit. Older aircraft types such as the Boeing 757, 767, and other older generation models have been replaced by Airbus 321neo, 330neo wide body aircraft going to Asia, and the smaller A220, which goes to some lesser traveled destinations. And then we have also placed orders for the Boeing 737-10 MAX aircraft. So, these new generation aircraft have much quieter performance. Their fuel efficiency is greatly improved. And in the case of the A220 and the A321neo, they both have a noise footprint, which is actually 50% lower than some of the airplanes that they replace. So, and along with that, we're really trying to move ahead with the new technology, and we'll try to continue to do so as we can.
Thank you, Tony. I'm a bit nostalgic. I mean, I've always loved the Boeing 757, and the takeoff performance of that aircraft is
it's a great airplane, and we have a few left, but they are slowly leaving the fleet as we speak.
Yeah. Thank you. Lene, what's your perspective on this?
Similar to Tony, we are, at Alaska Airlines, we've invested a lot in new Boeing MAX aircraft, and we've taken delivery of, I think, about 80 of those aircraft now. And so we're seeing, again, much quieter footprint. So it's a benefit everywhere we fly. So I know there've been a lot of questions tonight about a specific flight path or neighborhood, but these quieter airplanes really do help reduce the noise impacts close in, far away, and in every community we serve. Specifically at SeaTac, another one I think Tom or maybe touched on it earlier is working with the port on a few noise reduction efforts. Single engine taxi is a big one for us too. That's helps our sustainability goals as well as it does reduce noise. We really like that partnership where it's a win-win for the community, for the airline, and the airport, where we can have a quieter operation, a more fuel efficient operation. And another one that's recently come up is in collaboration again with the Port of Seattle. Not so much the noise, but more a little bit, but emissions and noise is working with them to replace some of the air hoses that go to the airplane. So if you've ever been on an airplane that's either too hot or too cold, we partnered with them to find a way to get some better air hoses that they installed at all the gates, and so that keeps us prevents us from having to run what's called an auxiliary power unit. It's a little tiny engine that helps provide power for the air and heat in the airplane. So even things like that, we're finding ways to help reduce both the noise and the emissions.
Excellent points, and it's all in the details. It's all in the details. Next question, are there any plans to reduce the aircraft noise over Northeast shoreline? Sean, can you help us with this?
Thanks, Grady. Yeah, again, it gets back to just volume and how far away. Well, let me back up. The volume of aircraft that are coming into land at Seattle will dictate where we are turning final. And while we want to maintain safety, we also want to be efficient. So the goal from the air traffic side is if we could turn everyone through Elliott Bay, or give the pilots or the aircraft coming in the shortest possible routing to the airport, that's what we'd like to do in most cases here, because we do have quite a bit of volume at times. our final approach course gets extended out, and those aircraft are turned on again anywhere from 5 to 25 miles to set up for their final approach. And again, it all gets back to providing the pilots in command the opportunity to set up for a stabilized approach to come in and land at Seattle.
Thank you, Sean. And Lene helped take us through what stabilized approaches mean. So I think she's helped us cover the rest of that topic. So thank you. Thank you both. Next question is, when can we expect the Green Skies automated systems for the eastern side of approaches? Sounds like someone just said in the next year. Is that accurate? How will that change flight patterns for the southbound eastern approach? As it is my understanding that those flights will now be able to be pulled more southward for greater fuel efficiency for those coming from the south. Let me take a stab at this one. Currently, there's nothing specifically planned for procedures in that area. However, the implementation of the new procedures, as Jeremy has mentioned, the implementation of new procedures is a lengthy process. It takes several years. From an airspace change need being identified to design to implementation. With the growth of the greater Seattle area population, growth at the airport is certainly expected and is forecasted. And we're going to need to maintain the highest level of safety and efficiency always. I do want to stress that the FAA process for these types of airspace changes do include multiple points of community engagement throughout all levels of that project. So beginning very, very early on and throughout the process, multiple points of community engagement are expected and are put in place. So again, it's a bit premature for that based on the question there for the eastern side at this point. All right, Sean, did I miss anything?
I think you covered it. Thanks, Randy.
All right, Lene, anything to add on this?
Just, I think we've kind of covered it. We want to be as efficient as we can, and that can mean, whether we're turning in closer to the airport. We do have flight procedures that, coming over Vashon that would turn over Elliott Bay. Again, we can use those when the weather's really good and it's not super busy, but there's always a balance between that traffic volume and how busy the airport is, and what FAA tells us when we ask, hey, could we use a little, can we have more efficient or shorter routes to get into the airport, is these sequencing and spacing tools. So the air traffic controller has to be able to, I think somebody in a question earlier said something about zippering them, right? And so that we have to be able to come from the east and the west to get into that north-south alignment safely first and then efficiently. But yeah, we're happy to have conversations with the airport and FAA about, how we can improve airspace efficiency.
Yeah, thank you, Lene. That's very helpful. And Jeremy, question for you now. And this is similar. Why did you choose the west side instead of the east side for greener skies?
Yeah, so Greener Skies was a regionally developed plan to utilize satellite-based procedures and to do so in collaboration with a local air carrier that had a high percentage of aircraft that were equipped to do so. When it was being developed, the flight procedures west of Seattle were addressed first because that area is a lot less constricted and complex than the east side of the airspace. This was a new concept, and the airlines had already been investigating the concept, specifically also on the west side of the airport. And so the east side did present sequencing problems with the current technology that was in place. And so the decision was made to start with just the west side only.
Thank you, Jeremy. Very helpful. Next question. Can you clarify changes in the south flow pattern approaching from the east in the past 5 years? And the logic in having planes from the south fly very far north, 15 plus miles, before turning south, whereas on the west, they often turn much sooner. For example, planes never turn south of 520 on the east, but do turn over Elliott Bay. This happens irrespective of the time of day and or congestion. For example, at 1:30 a.m., a plane will fly from the south 15 plus nautical miles north to northeast Seattle before turning south. Sean, can you enlighten us on this?
Yeah. Again, it's the flight paths and how far they're extended north on a south flow arrival is going to be dictated by volume and current procedures we have at the airport. Current procedures allow controllers to turn aircraft as close in as Elliott Bay on the west side of the airport. But again, as it's currently established, we have to go north of the 520 bridge before we can turn in for final on the east side. Again, at that point, we're trying to mesh the aircraft from the east side with the aircraft from the west side. Sometimes we're lining those aircraft up for 16 right, and we're sequencing to that runway. And there are times where we are also establishing aircraft for landing on 16 left. We have some in-trail restrictions because of airport geometry again, that dictate the spacing that we use between the aircraft that are landing 16 left. So there are a lot of factors that go into it, but again, the reason that we do turn the aircraft where we do is based on volume and current procedures that we use.
Great, thank you very much, Sean. Next question, are there no limits on the hours large commercial planes can fly over residential areas? Let me restate it. Are there no limits on the hours large commercial planes can fly very low over residential areas? Planes are flying low overhead starting at 4 a.m., so low that this participant can read the logo on the plane. Ryan, share your thoughts with us on this.
Yeah, so SEA is open 24 hours per day, and there are no restrictions on when aircraft may operate. Local airport operators, such as the Port of Seattle, do not have the authority to impose a curfew or restrict operational access to the airfield. And as Grady touched on earlier, the Airport Noise and Capacity Act, or ANCA, of 1990, is a federal legislation that establishes the rules and limitations of airport operators. But as Tom has also touched on, and as Lance did in the introduction, we also have the voluntary late night noise limitation program, and through that, two of the primary ways that we encourage the air carriers to reduce late night noise is by operating during less noise sensitive hours, or by transitioning to quieter aircraft.
Thank you, Ryan. That's very helpful. So the next question, I'll take this one. FAA was supposed to announce the formation of an Airport Noise Advisory Committee as required by the FAA Reauthorization Act of 2024. Why didn't it? At FAA, we do have a website that's focused on our noise policy review, and we can provide the link to it, and we will provide the link. That site provides detail on the ANAC, or the Airport Noise Advisory Committee, and FAA does update it regularly. We encourage you to sign up for those updates, and emails will be sent to you anytime the website is updated. All right. Next question. And Ryan, I'm hoping you'll help me with this. Where can I submit a noise complaint?
Yeah, so noise comments can be submitted to port staff 24 hours per day through various methods. We have our hotline, at 206-787-5393. That's 206-787-5393. And then we also have our email address at noiseprograms@portseattle.org. Comments can also be submitted via the online comment form on the Port's website, which can be found through our Port of Seattle's Aviation Noise Program webpage. There's also an SCA mobile app to submit noise comments, and that is operated by Plane Noise. And then in addition, the Port uses Public View as our flight tracking tool, and that can be accessed via the Port's website as well. So comments can be made there by simply, resident can go in there and simply go through the history, go backwards in time and click on the flight that they were concerned about or had a comment about, and submit their comments that way.
Wow, I mean, that's impressive, Brian. There's multiple channels that you've laid out there for all of our neighbors that they can pursue. And I would just add one more. For the FAA, you can submit a noise complaint through the FAA's noise complaint response portal. And that address is https://noise.faa.gov. All right, now we've come to the final question. It sounds like the FAA in this forum is more of a lecture on how everything you've done is logical, and here is why it is the way it is. Rather than actually listening to people suffering from this noise and finding ways to prioritize public health. How is this an inaccurate depiction of this meeting? So, I mean, we know it can be frustrating to hear that something that you find to be a problem, it doesn't have a quick fix. Some things are just multi-layered and very, very complicated. We found that the most effective method of engagement is engagement and discussion so that our communities may better understand why flight paths and aircraft cannot be changed from where they are today. We understand that our answers may not solve the problem for you today, but that we do remain committed to continue the conversation. So, Sarah, can you help address this final question as well?
Yeah, I just want to know, community engagement it's extremely important to us at SEA. We try to provide many venues, forums, formats on how to engage, whether it's on noise, some of our other environmental programs as well. And this feedback, I mean, it's really been a foundation of some of the programs that you've heard about tonight. And also on how we're looking at the shape of future programs as well. And it extends, beyond noise. It's, other pollution prevention, our greenhouse gas emission reduction programs. And, I think, these are really challenging, issues to solve. And we are continuing to try to move forward to come up with ideas, pilot programs. And I also just want to say at the port, at SeaTac Airport, we also have leadership that this is a primary focus for our leadership, and they provide support to us to engage in these innovative initiatives. So I guess I'll end with that. Thank you.
Thank you. Thank you, Sarah. And Tony.
Yeah, no, it's a really good point. And we at Delta, and along with Alaska and all of the other stakeholders here, we do continue to participate in community engagement. And that has also allowed us to hear and get feedback from the community. And it's helped shape our sustainability goals, led to investments in technology. And as Lene mentioned, we have been able to adjust some of the operating methods at Seattle, and not only Seattle, but other airports in which we serve that help maybe fly a aircraft in a quieter manner, like with an optimized profile descent, or we don't run the auxiliary power unit at times because we've improved the air hoses. So all of these ideas do come together and help us reduce our noise footprint, and it's a collaborative process, and we're going to keep working toward making things better as we go.
Yeah, indeed, it's a journey, and there's multiple paths to take and to collaborate on different creative approaches. But it's step by step. Sean, share with us your perspective.
Thanks, Grady. Yeah, I just want to end with from the air traffic control side, as we provide safety and efficiency for air traffic in the Puget Sound area, we do and we are committed to being good neighbors as we do that. The air traffic side and FAA is going to be at the table to have those discussions and look at how we do things, and if there's better ways to do that, and things that we can always look to be better. So again, we do have the overarching goal of being safe and efficient and providing that for our air traffic customers throughout the Puget Sound area. But again, we are committed to being good neighbors while we're doing that.
All right, thank you very much, Sean. And Lene.
Sean made a great point there. I think part of today's conversation, it helps to show that we focus on safety as our absolute top priority. And I think in the context of noise concerns, it's challenging to understand just how complex the airspace and the airport operation is. But there's a high degree of training and professionalism on the airline side, on the airport side, on the FAA side. And I think the goal today is to kind of just share that we do focus on safety first, and yet noise and community concerns are always part of the conversation as well. I'm on a lot of industry forums across the country, and community noise concerns are always part of those conversations. And so, again, as I think somebody else mentioned, it may not feel like we're solving the concern that you have today, but it's important to hear voices of the community so that we can find that framework to keep getting better.
Excellent points. So I'd like to thank all of you again for joining us this evening. I'd like to share that seven out of eight panelists live here in the Puget Sound region in either King or Pierce counties. We are your neighbors. We heard your desire for alternative engagement beyond the START Community Roundtable. And at this point, there are no proposed approach or departure procedures to review. And as a result, there's no mandatory reporting requirements in place for us. The stakeholders, including the airport and the airlines and the Federal Aviation Administration, continue to collaborate on innovative methods to better address all community concerns. This webinar is an example of our ongoing commitment to engage in meaningful communication. You may not have heard what you wanted to hear tonight. You may have submitted a question that you feel we did not address. I encourage you to submit remaining questions through the FAA's Noise Complaint Response Portal. I mentioned that address before, and here it is again, https:// If you'd like to view this workshop again, please visit the FAA's YouTube channel. This workshop, it was informational only, and it's part of an ongoing dialogue between the FAA and our external stakeholders. And again, thank you for joining us this evening, and take care.